Name's Evan. We're going to be going over software architecture, and we're going to start with our problem. So we're examining this topic because it's essential in software engineering. It's a great tool that can be used when you're creating a project. So what is it, and what is software architecture modeling? Well, software architecture is just the fundamental structure of a software system, and the model is a visual representation of that. I'm studying this because it's incredibly useful in almost every scenario when it comes to development. Knowing how to design a software system properly is extremely invaluable information. Modeling software is just being able to draw detailed diagrams and understand how a software system works. And that's very useful when you're managing large-scale applications. So my three pieces of literature were Software Architecture by David Garland, Software Architecture Patterns by Mark Richards, and Software Architecture: The Next Steps by Jan Bosch. So the first article, it just discusses many key terms and concepts in software architecture in general. The second one looks into different types of software architecture models. And the third one kind of just looks at current problems and thinks of ideas and solutions for how everything can be implemented in the future. So to begin my critical analysis, we're going to look at the first article, which, like I said before, examines important key concepts in software architecture. So here, Garland discusses view classes for such models, and these include code-oriented views and execution-oriented views. So code-oriented is kind of just models of software, like how it's organized in the code, and then execution-oriented views are how everything happens when the program is run. His second insight discusses modeling software using what he calls first-class identities, which are components, connectors, and systems, and these all tie in together to create a software system. So continuing my critical analysis with the second article, we look at 5 different types of architecture models. So the first is layered architecture, which is a model where the system resembles a tier-like structure that matches the organizational structures of many real-time companies and business application development efforts. Event-driven architecture is great for large and small applications, as well as scalability. It's made up of these decoupled single-purpose event processing components, and these can just send and receive events back and forth. Microkernel architecture follows a natural pattern for product-based applications. This includes things that can be packaged and distributed as a third-party product, and it also includes things like plugins or feature isolation. Microservices is a new industry standard. It's utilizing cloud components and it controls these multifaceted software systems. Think of a software where there's a phone, there's a website, there's a computer application, and each of these connects to a number of services. You're also hosting, let's say, millions of users. You have too much going on that it needs to be in these microservices, which can individually control and streamline all of your software processes. Space-based architecture follows these web-based business applications where we're working with requests, and these requests are being sent and received between a server, computer, and a database. And our final article just looks at the future of software architecture by revealing past problems. And these include lack of first-class representation, design decisions that were too intertwined, high cost of change, and the violation of some of these design constraints. And it offers ideas for the next steps of modeling. Bosch also offers some insight into thinking differently about structural patterns and thinking of software systems as decision processes rather than just sets of components or sets of code. So for my evaluation, just based on the literature, there are numerous things to be said about software architecture. The first would be that it's not perfect. Every application is a lot more than just a drawing, and representing an entire system is often pretty hard. So despite that, there are numerous types of models that can be utilized to effectively work for your system, and many of them will be successful. And finally, the future of software engineering has a lot to bring. Many of these new cloud-based services are leading us to an increased use of microservice architecture. Now, will that stick around for a while? I guess we'll see. So the thing I found most interesting was the different types of architecture models described in Richard's article. And it's cool to me, at least, to understand how and why each of these are used and which I can consider using for my future endeavors. That's it. That's all we've got for software architecture. Thank you guys for watching.